Greetings. Welcome to my new calculus channel. My name is John Gabriel. And today I'm going to be discussing a video which has a lot of views on it and is supposedly or purportedly by a great educator, one called Reynaldo Lopez. And while I go through the video, I shall be telling you what is wrong with it and how you can better understand pi. Okay? So, as you've seen here, I've written there are so many things wrong with this TED lesson that it's quite a lot of work to debunk. And I start with the very first thing. So let's watch the video and see what happens, okay? Great educators and animators.
Try to measure a circle. The diameter and
So the first thing you hear is try to measure a circle. Well, this is the first clue to the unknown fact that modern academics are inherently ignorant and stupid. What does it mean to measure? Okay? To measure a size, an amount, or degree of an object by comparing it with a known size object. Okay? That's what it means to measure. So not only does the presenter not understand measure, but he doesn't mean anything having to do with the measure of the circle. What he means is the measure of a circle's periphery length, as will be seen shortly. Okay? So let's continue watching.
radius are easy. They're just straight lines you can measure with a ruler. But to get the circumference...
Did you hear that? The diameter and radius are easy. They're just straight lines you can measure with a ruler. Well, that's not true. It all depends if the diameter or radius is composed of the chosen unit and or parts of the chosen unit. This is very important. Mainstream academics have never understood what it means to measure. Okay? But to get the circumference, you would need a measuring tape or a piece of string.
You'd need measuring tape or a piece of string.
The ignorant educator imagines that measure is an actual physical process that depends on rulers, measuring tapes, and strings. However, the measure requires nothing but the chosen unit and at that an abstraction of the unit, okay? All numbers are abstract. It requires nothing but the chosen unit and a means of using the unit to express the size or magnitude of the circumference. So you don't need a ruler or a measuring tape or a string.
Unless there was a better way. Now, it's obvious that a circle's circumference would get smaller or larger along with its diameter. But the relationship goes further than that. In fact, the ratio between the two, the circumference divided by the diameter, will always be the same number, no matter.
I just noticed that he said the ratio of the circumference divided by the diameter. Well, it's not actually divided as such. A number has no division pending. So if I had to write 3:1, there's no division taking place there. And if I write 3 with a vinculum in the middle and 1 at the bottom, that's a complete number. It's the number 3. There's no division pending, okay? So anyway, he says the ratio between the circumference and the diameter will always be the same number. Now let's see why that's a problem. Well, what is a ratio? Clearly, the presenter and author of this video have no clue. A ratio is literally the comparison of two sizes or magnitudes. The ratio cannot be a number unless its parts are numbers. In the ratio 3:4, the antecedent part is the 3 and the consequent part is the 4. If we write the name of a size being described, then we write 3 vinculum 4 and 3 is called the numerator and 4 the denominator. So 3/4 is a well-defined number. Circumference length as a ratio to the diameter is not a number. The diameter is assumed to be the unit which cannot measure the circumference of the circle. Usually the consequent is understood to measure the antecedent, or the numerator. Euclid talked about the smaller measuring the bigger. My article, that you can see the link here on LinkedIn, or you just type how we got numbers, explains to you the perfect derivation of number from nothing, okay, and what it means, in fact, to be a number. Let's continue.
No matter how big or small the circle gets.
Okay, well, first of all, the circle size doesn't change, okay? It doesn't get smaller and it doesn't get bigger. All known circle sizes have always existed, right? But all circles are in proportion, and this is proved easily using Euclidean geometry. The thing about modern mathematicians, they're not mathematicians because they don't really understand mathematics, is that they've never understood geometry or the elements of Euclid. And so these things are just typically forgotten and placed in the background, but they are the most important concepts in understanding a number, for you cannot understand how we got numbers until you understand that all the arithmetic operators were possible without numbers. In other words, just using geometry. Let's continue.
Historians aren't sure when or how this number was first discovered, but it's been known in some form.
Wow. Ignorant historians are not relevant. Any individual with a modicum of intelligence will begin to suspect something if after each time he uses a circle's diameter as a unit to measure its circumference, whether using a piece of string or a cloth or anything, the result is approximately 3. Even a moron can discover this fact with only a piece of string. Then he says it's been known for almost 4,000 years. Actually, the size, not the number, described by this ratio of sizes, exists independently of the human thought or any other thought. Whether one realizes it or not does not change the fact that pi is a nomenon, or a perfect concept. I don't know what that little bell was about. And in any case, I think I'm still recording. So the next comment says, so when did they figure out the exact value? Actually, never. Ironically, the presenter talks about an exact value, but it is from an exact value that we are able to give the size or the magnitude a name, that is, a number. Did you get this? He is correct that an exact value cannot be figured, because in order to arrive at an exact value, one would have to measure the size known as pi, not approximately, not partially, not to 6 quadrillion places, but exactly. It can't be done because infinity is a junk concept. Then at 120 he says, you see, the ratio of a circle's circumference to its diameter is what's known as an irrational number. Well, it was known as an incommensurable magnitude, or a size, by the ancient Greeks, whose clarity of thought was not matched by any before or after them. An incommensurable magnitude, in Greek alogos meiothos, is a magnitude that has no common measure with any other magnitude. It's ironic, again, that the presenter calls it an irrational number when it has not been measured, and a number, by definition, describes the measure of a magnitude. So he says then, one that can never be expressed as a ratio of 2 whole numbers. It is a little known fact to the morons of mainstream academia that all numbers are ratios, and ratios came long before natural numbers or whole numbers. In fact, both those are ratios. Every number is a ratio without exception. Thus, if the size cannot be expressed as a ratio of known sizes, then it is not a ratio and hence not a rational number. There are no other numbers besides the rational numbers. Then he says, and continue forever. In other words, impossible to measure. Infinity is a junk concept because it cannot be reified in any form or shape whatsoever. There is no such thing as forever because forever cannot be completed. It is a super task which is impossible because there is no end. And then he says that's why instead of trying to write out an infinite number of digits each time, we just refer to it as pi. There is no such thing as an infinite number, which is a phrase that implies completed infinity, a double junk concept. Indeed, the incommensurable magnitude is known as pi, which is not a number, but a name given to a size that cannot be measured. And then from 2 to 218, we have irrelevant and unremarkable information. I cannot imagine anything more stupid than memorizing digits of pi, which are not in any sense unique. For any given n digits of pi, I can prove there are innumerably many rational numbers with the same n digits in the same first n places. How stupid can one get? Then at 219, he says, for most scientific uses, you only need the first 40 digits or so. Well, that's entirely false. To arrive at a decent estimate, depending on what error you set, it all depends on what magnitudes are being used. So if you look at galactic magnitudes in terms of light years, the first 40 digits may not even be close enough for a reasonable estimate. The remaining video is unremarkable, and the information which is given does not help in understanding the immeasurable magnitude pi. Okay, so I've given you two links here, the link to my new calculus site and also to my videos. I strongly recommend that you visit my site and study my work so that you can learn exactly what is a number and become very good at mathematics. My name is John Gabriel, and this is the New Calculus channel. Thanks for joining me. Till next time, goodbye.